Okay, so we've already done one example, and I forgot to record, so I'm going to start recording on example 2. So what we're doing is we're proving trig identities, and what we talked about, the important part was we're going to either work with the left side to make it equal the right side, or we're going to work on the right side to make it equal the left side. And this is where there's not an answer key, because there's not just one right way. There could be multiple correct ways. Alright, so this side looks more complex than this one. So let's see if I can turn this side into this side. Alright, so we're going to work on the left. Alright? Alright, who has an idea? Okay. This is tan. Alright, so this is tan squared over secant squared theta. Alright, so those are equivalent statements. So now what can I do?
Change tangent.
Change. I like it. So sine squared over cosine squared theta over.
You can keep change flip.
Can you just cancel by cosine?
Alright, I think I'm going to give detention if anybody else says keep, change, flip. Alright? Because I'm afraid it would be scary if you went to calculus and said that. Or even scarier if you went to college
Dang. Al,
and
you're
said
getting
that.
roasted.
Alright, so thank you. That's right.
What did he say?
We're going to change this to multiplying by the reciprocal here.
Which
Because
is
that's what division of fraction does.
which is absolutely
So
not.
keep, change, multiply by the reciprocal.
Alright. And so we're left with sine squared theta equals sine squared theta.
We proved it's right.
Check!
So
We
if
did
it's
it.
not equal,
We know it already works.
Alright,
if it's not equal, it doesn't work. So let's just.
Or you just
that's
did
one way we can do it.
Oh, it's easier because you can't get it wrong. You just got to do the middle stuff.
Right.
Okay, bet.
That's why. That's also why you can change flip one.
Okay, okay. I agree with most of your statement. You know what the answer is.
Right.
You know what the problem is, you know what the answer is. But every step in between has to be accurate for you to get the points.
Oh, crap.
So, let's see if we can think of a different way to do this one. What if, I'm still going to work with the left side, but is it fair to take that fraction and break it up?
Are we ever going to do that?
Oh,
Okay.
sine. I need cosine.
So, what happens here?
That becomes 1.
That's 1
This is 1
minus cosine squared.
minus cosine squared theta, which is sine squared theta.
That's how I was gonna
Did
do
we
it.
do it?
Yeah, that's the way I was
Okay.
thinking in my head.
Wait,
That's so deep. Don't lie to us.
All right.
I didn't know.
This way's right.
It's so much more.
This way's right. That's why there's no answer key.
Wait, what? That's why it's
Special.
I think
Because
there should
it
still be an
depends
answer key.
on what you see first
Wait, how did you?
as to how you start the problem. Now, what's going to happen is sometimes you're going to go, oh, let's see what I can do with this left side. And you're going to start working and you're going to like, oh, I'm in a circle. That didn't help. Now what? I don't know. And then you're going to want to attack the other side.
Stuck in the room.
So sometimes you might, when you get stuck, start over.
Can you do
Try it
the
a
right
different
side?
way. Okay? So let's take a look at this one. Example 3. On this one, we're going to do the right side.
Ooh, that just close enough.
Okay, so we're going to do the right side, and I need some ideas.
Okay, then. We can change. You can pull out the 1 and then like cosine over is going to be cosine. No, don't do that.
Separate it.
Separate anything in that column.
You can't, because if we had a sum in the numerator and a single denominator, you can split it, but you can't split this. This is our only denominator.
Factor.
We have a
She went on the
problem,
other side.
Yeah.
don't we?
They don't
We have a
equal.
problem with our problem.
No, it's don't
But watch. This is going to fix things.
Oh.
I never.
Why would this fix anything?
I forget
Because
what
then
you
we
call
can
it, but
replace the bottom with cosine.
It'd be squared and then it could be cosine.
Okay, so when I multiply here, I get cosine of x. 1 plus sine of x is my numerator. And when I multiply my denominator, I get 1 minus sine squared x,
Just cosine.
which is cosine squared, isn't it?
Yeah, I would never thought of that.
Yeah, how are we supposed to just think of that off the top of our head?
So you can just-
Identities.
So you're not just pulling that out of nowhere. That you can only do that when there's like a 1 minus sine x.
To be in class.
It's not in the cosines.
It's a little bit. I don't know if you just heard what it said.
There's a reason I may have picked this one as an example, because I don't think intuitively we would have all jumped to that. But I've done enough of these that when I look at it and I'm like, well, I don't see a single identity. I've got to force one to happen. And so whenever I have this, I always think about it. Conjugate. Yes, sir.
What's the reason for writing 1 plus side? Like, why do you do that again?
Identify as
Okay, because I know that a plus b
Equals
times a minus b is a squared minus b squared. I know that my Pythagorean identities have to have sine squared, cosine squared, tangent squared, cotangent. They all deal with the squares. So I created one. So when I have the minus, I created a plus. Now, is my approach the only approach? No.
Oh wait, I
Just
just
the
saw how to
way
fix that.
okay, what do you think?
You like cancel them,
Yeah, you do.
and then you separate them.
And now we
And
can
then-
separate them.
Oh wait, no, because then it's
So we
negative.
get 1 over cosine x minus, this is plus. I just changed the sign for fun incorrectly.
Hurt my brain.
Okay, so what is 1 over cosine? Secant x plus tangent x. Da-dun! We did it.
Okay, but.
I'm saying that.
That could be a song.
Okay? So sometimes we may see the left side quicker. Go with it.
So what I've noticed is all the ones that we're solving, we're like finding they have to equal to one, just one, like trigonomic, like function. It's
Well,
not
it really
under-
just depends on what you start with.
Yes.
It is possible that I could have started with multiple. See, on this one I had a sum over here and a product over here.
Okay. Like the ones I realized that we do, they're all refraction.
It's a little bit of everything. It's a little bit of everything. Okay. So today we have practice with this. Tomorrow we have more practice. So we'll start off with maybe some simpler ones. We'll work our way up to some that might take a little more thinking. And tomorrow I am not here. Possibly. I'm supposed to be taking the math team to a competition. We can get this bus situation figured out.
You still something illegal yet?
It's okay. That happens actually. Team
So,
The Willoughby spin.
math team will know at some point today if it's a go or a no-go.
Wait, we
I'm
might not be going
trying
as a
really
whole.
hard to make it a go.
Decorate the bus.
So
Wait, there's a chance we might not be going.
we'll go. We just have to make it
Wait,
work.
you have to go on that Friday?
So,
That's rough.
You didn't even get to
so tomorrow, guys, you're not listening. Tomorrow, I'm not here, and my sub is not a math teacher. So, you are to work together. No. And they may end up pulling my sub to put somewhere else. So, I'm not certain exactly who it'll be yet. But you know enough to do the problems I'm leaving. Some are going to be challenging. Okay? And I will tell you, I'm worried about some of you skipping steps. And I'm not worried about others. Because some of you are really good at showing me all of your work, and it's very logical. That's what a proof has to be. Math magic cannot happen. If it does, you don't get any points.
Math magic.
Because we all know the answer. We all know we're looking for this, or we all know we're looking for that.
I was.
No.
So every single step in between is critical.
What if you started with this?
See,
There's
I
so
always
much
thought
like
it was
solving
when I saw you.
Do we have the
guys
number of,
skipping
like,
all
the number of the
answers,
steps?
and I-
No.
Really, I was.